Good morning, students. Welcome to Physics class, Chapter 8 Wind, Storms, and Cyclones. Let us start with air current. Air currents are concentrated areas of winds. They occur mainly due to differences in pressure and temperature. Let's learn about warm air and cool air. Air becomes warm when it comes in contact with a warm surface. The molecules of air move further apart when it becomes warm. Since molecules are far apart, the air pressure is low. Now, about cool air. Air is generally cooler in high altitudes. The molecules of air moves closer to each other when the air is cool. Since molecules are closer together, that is denser, the air pressure is high. Air moves from high pressure region to low pressure region. Air becomes warm when it comes in contact with a warm surface. The molecules of air move further apart when it becomes warm, whereas the molecules of air moves closer to each other when the air is cool. So, warm air which is lighter rises up and cool air which is denser moves down. This concept is known as convection current. Sun is our main source of heat for Earth. Some parts of the Earth receive more of the sun's radiation than others. The main reason for this is the curvature of the Earth, as the Earth is a sphere. This curvature means that at higher altitudes, the radiation from the sun is spread over a much larger surface area, while the same amount of energy is much more concentrated near the equator. The radiation also travels through a greater depth of atmosphere nearer the poles in comparison to the equator. Also, the tilt of the Earth means that polar regions do not see daylight during winter. These three reasons of Earth curvature, depth of sun's radiation, and tilt of the Earth gives the uneven distribution of sun's radiation on Earth, giving us the three major temperature zones of Earth. The torrid or tropical zone near the equator, where the temperature is high. Temperate zone, where the temperature is relatively warmer. And the frigid or polar zone, where the temperature is very low and cold. Different parts of the Earth heat up differently, with the equator receiving more radiative heat from the sun than the poles. And the purpose of global circulation is to redistribute this heat. If the Earth did not rotate and was a simple mass with no oceans, we would have a single circulatory cell where hotter air would rise from the equator and float towards the poles. The air would sink as it cools and then return towards the equator. But the unequal distribution of land and ocean and the speed of the Earth's rotation makes this circulatory system a little more complicated. The unequal distribution of land and ocean and the speed of the Earth rotation make this circulatory system a three-cell pattern which exists in both the northern and southern hemispheres. The largest cells are the Hartley cells. At the equator, the warmer and the less dense air rises. The warm air spreads out towards the poles, gradually cooling and sinking as it moves before descending to the surface and flowing back to the surface and flowing back to the equator. The smallest cells are the polar cells. Cold, dense air descending in the polar regions flows north or south. As the air leaves the polar region, it starts to warm and rise, returning to the poles at high levels. Between the Hartley and polar cells are the Ferrel cells. Unlike the other cells, the Ferrel cells are not driven by temperature. The cells flow in the opposite direction to the Hartley and polar cells, acting like a gear. These circulating cells not only transport heat from the equator to the poles, but also results in semi-permanent areas of high and low pressure. The rising and descending parts of the circulation cells gives us the climatic zones. The region where air is rising, that is an area of low pressure, is created. So these areas see more rainfall. This is why the largest areas of rainforest are found near the equator. The regions where the air is descending, that is an area of high pressure, gives very little rainfall. This is why most of the deserts are found near such high pressure regions.